Okay, so in this presentation, we're gonna talk about record linkage and data matching. I hope you will get some information about what you can do with the real data sets. So we're gonna wait until 4 to start our presentations. Yes, sometimes it's weird, don't meet in person, and then you can see the faces if you go there and here. So if someone understand you or not. Yeah. Yep. Yeah. Thank you. So do you have any information about fuzzy matching? Do you know what's going on with the algorithms like fuzzy matching, our record linkage information? Okay. Yeah, I hope you will get some idea about it within this presentation. And we know some of the basic concept of it. So we still have 5 minutes to start. Okay. Yeah. Okay. This is data linkage. We will go through it. What's mean data linkage? How we can link? It's just has different names. One of them is data linkage. Another name is deduping. So independent how you are dealing with the data, I'd give different names. So data linkage. So we go with the basics of it. We will show some coding. So we can go. So we will go through examples. How does this one work? And I hope this will be good introduction for everyone who doesn't have an idea about data linkage and deduping and string matching. Yeah, we're still having 3 minutes to start. Yep. So 1 hour, 2 minutes, so 2 minutes, and then we go start our presentation. Yeah, there is like a time left, like 1 hour. I don't know what will happen after 1 hour. So it will be end the recording, or what will happen, we don't know. So say like time lifting is 1 hour and 2 minutes. It's really weird. Yeah, so we will start 4 sharp. This is what they try. Okay, so let's get started. Okay, what's record linkage and deduplication data? So in this presentation, we will go like with overview. What's the algorithm that people use for record linkage, and also with record matching or deduping. So in this talk, I will just go over quick introduction about the problems, explain some definition, what's going on there, and what's this mean. And then after that, we will go with some algorithms like fuzzy matching algorithm, and also some machine learning algorithm that we use. Why we using machine learning algorithm? We travel between fuzzy, so we see the limitation between the algorithms and how we solve these limitations. So, and here, so what's mean by data linkage? So data linkage or record linkage is the process to identify same name or same entity. So we are looking at the whole data, and then we try to figure out which the data is similar to each other's, or they are matching. And this way of looking for the data, it's called deduping if we are using same data set or database. If it is different database, we call it record linkage. So it's a process to identify the record that refer to the same entity within across databases. Okay, sometimes people give it different names: entity resolution, object identification, duplication deduction, etc. So in this example, we are like comparing data to identify record that represent the same string. So we are like using some information about people, and then we try to figure out is this people is the same or not the same. Okay, so let's go with the real example. So for an example, we have one customer, it's called Matthew, and this customer's, he went to, let's say, Target, and then he asked for loyalty card. And then when the cashier give him loyalty card, he will give him also a form to fill up. So the Matthew, when he filled up the form, he write Matthew, his birthday, is all information, the address and stuff, and he give it to the cashier. After a while, Matthew lost his card, and then he went to another Kroger, or maybe it's same ones, and then he requests a new loyalty card, and then they give him same things in application, our form. They ask him to fill this form, so he filled the form, and this time he's in hurry, or he just write Matt instead of Matthew. So he write Matt, he send the date of birth, maybe same different address or same address, and then the problem is in this one, it will generate a new record for him with this new ID. So now same customer with two IDs. So there's in a database now we find duplication. So we cannot, since the ID is different, now we cannot in general word we can write a query and then we look for him. But since the first name is different between Matthew when he wrote it the first time and then Matt, is now the query cannot figure out they are matching or not. So for an example, and here's some of the data that come. Fake data is not like real data, but this is a patient data. And then, so this is some information about Matthew. So sometimes he came to the one time to the clinic, and then he write Matt Jacob, and then his birthday, and then he wrote his address. So we can see that he wrote his social security. This is fake data, so it's not HIPAA violation. And then he come back to then another clinic of the same clinic, and then he wrote his different information. Now he wrote Matthew full, and then he gave more in the zip code information. He write the social security number and etc. And then he come back 3 times. So it's, and then he also insert a new information. So because what's happened is some nursing sometimes they will not ask him if he is existing patient or not. Or maybe he came back after 1 year. He think that his database is not recorded yet. So I was working in University Louisville Hospital. I work in Mortensen Dental Partner. We find a lot of this same exact problem. So because what's happened is we have free typing. So when they submit, when the patient come, they give him in a form, and then they ask him to fill the form. And he sometimes he never mentioned that he is existing patient. So when he's not, so the nurse will read the data and then just insert a new patient to the database. So why this problem is big? This problem is big because if you are like Target, for example, or Kroger, for example, the problem is sometimes you need marketing. You need the history of the customer. So you need to look at the whole history of the customer. You want to look at the shopping habit. So you want to see what's this customer like, what it does not like, and then you can target that customer with certain products. And the other way is if it's a clinic, the provider or the providers always try to look at the history of the patient so he can get very good idea about the patient. He doesn't want to see a new patient and then he start asking questions and then fill information. Maybe the patient will not mention everything that he has. So the good thing is if he has the history of that patient, he can read the history and then see what's going on with that patient, so they serve him is better and give right diagnosis. So this is the two ways of looking at it. But the record matching is very, very important in industry. So probably if you work in a company, we dealt with this type of data. We are like looking at the data and then we try to figure out how to fix it. The problem is if we are at SQL query, the data is not. Is not matching everywhere. So if you said like, you cannot say this person is the same person because like it's just count how many letters, and then if you write MAT, it will bring all the names that has MAT in it. So SQL query and will not solve the problem. So people, what they think about something we call fuzzy matching. Okay, sometimes we have like a spelling problem, mismatching, letters replacing instead of A, E, T, double T, etc. So they say, okay, we can use something we call fuzzy matching or fuzzy string matching. In fuzzy string matching, we have two types. In this talk, we will go through it and cover it. In this talk is so one of them is called algorithms Levenshtein distance. It is very simple algorithm. It's just looking at how many different characters that between the two target, between the source and the target, and then give the distance. So for an example in here, if you look at the book and back, the distance between book and back is 2 because you have 2 letters. So the first O is supposed to be A, and then second O in the book is supposed to be C in the back. So the distance between the two is 2. Okay, this is one of the algorithm. And then the second algorithm, so it's the Levenshtein algorithms. It's looking for the distance between the two words. And then we have another algorithm. It's called Jero-Winkler algorithms. And this algorithm is more advanced. It's looking at the first, is not like what's the distance, but it look at where is the mismatching is. So between the target and the source. So it look at, if it is in the beginning of the word, it give it high weight. If it is in the end of the weight, it give it low weight. So for an example, so you look at Miss and Missy, so there's 86% is they are matching. Why? Because all three letters that match is the end, the front of the string. Okay, and if you look at the create and actor, there is different actor. So different a lot, because why? Because the first three letters and the source and the target is a huge difference. So the position in Jero-Winkler is very important to figure out the matching and mismatching. So it will continue and depend on the position and how many number of characters that difference. So these two algorithms that people use. So let's say in here, so we go with the demo. Yeah, this one is not, no, yeah, it's for any language. It's work with any language that you can use it for any language, not just English. Sorry. This one. Okay. Okay, so in here, so some small examples. So I have data in here. So I just put the same data, Jacob, Matt, and here's some other data, Matthew. So I am looking at it. So I insert this data. So you can see the different. Sometimes Matt, he write math, and then he say write Matthew, and then he write Matthew again. So last name in here Jacob, and then here forget the S. Maybe they missed the S. And then so let's say try to figure out, and we see the matching. So in here I am using a library from Python. It's called WYSI library that implement Levenshtein distance. This is look at the distance between the two strings. So if you run it in here, so I am downloading WYSI library, and then I say okay, the first name, I am taking 143 ID. He wrote it Matthew, and then for the ID 5543, this one he wrote math. Okay, so we have math, and then here Matthew. Okay, Matthew and math, and then also I get the address, and then I try to figure out the distance between the first word, first name, and the first between the both records, and then also for the both address, and then I try to find the ratio of the difference between the two. So you can see that the name ratio, the name difference between the Matthew and MATW is 73. So this is 73 because we are flipping. So every time it's high number, that's mean high related. So it's the 73%, they are matching. And then if you look at the address, so in here write Phil Boulevard, and here just write the PLVD left. So in here we see that 87% is matching. So if we want to combine the two and then divide it, this is we'll try to look at probability, and then I can find out that this two together is matching 80% matching for both record is a 143 and 5543. How it is good? Go letter by letter, and then and find the distance between the two. Okay. So now we know the idea. How does it work? So the fuzzy matching, we throw the difference between them. We try to find the distance between the two words, and then we get the percentage. So if you apply it in our database, we can use system now, and then we can figure out is this matching or not matching. So if I have two sources of data, this is source A and this source B, maybe two clinics that have two databases for patients, or two business that has two databases for customers. After I clean it, we clean the data, and then after we clean the data, we try to use fuzzy matching. This is fuzzy matching. We combine the first name and last name, address, date of birth, zip code, cities, and all the information that we have, and then we try to figure out how much there is a matching between the two. And then also we try to figure out how the probability if they are both of them is on matching. Okay, so we run the algorithms, and then we try to figure out what's going on. So in here, this is a small example. So I use record linkage library. This is a free library in Python, so we can use it. So this is, so I bring all the library that I need. So I bring the record linkage, indexing, and all the stuff that I need in here. So first things we're gonna do is we create, so since I have only this 6 or 7 entries, so I have to find the 7 entries as a double database to try to find the matching. And we can create a pairing, so I can loop and try, because let's say the 0 record, he will compare with the 1 record can compare with the 2 and 3, 2 can compare with 3 and 4, and 3 can compare with the 4 and 5, and etc. Okay, so what we do, the good thing, since we have a library, so we can do indexing. So from the indexing, we can create a new database. We call it the pair. So if I run this one, so this one, it helps us in two ways. One way, it will index the data. It make the data is fast for searching, and at the same time, it create a new pairs. New pairs, it mean that what's the data that we compare with. So if I have 7 record, I need 21 record to compare with. Why 21 record? Because 0, you will not compare it with 0. You want to compare 0 with 1. Okay, 0 with 2, 0 with 3, 0 with 4. And then 2, you will not compare it with 0 because we already did. So we compare it with 3, with 4, with 5. And then 3, we compare it with 5, 6, 7, etc. So if you have 7 records, it will generate 21 pairs. That's mean the data set will become 21 instead of just 7. And then we start comparing with. Also, okay, and then we start comparing. It's very simple way. So we have in here, we say compare. And then we call the library, it's called compare from the linkage, record linkage library. And then we say, okay, what we need to compare? We say, okay, we need to compare the first name for the both, for the pairs. So we will look at the pairs and we look at the real data. So first name, we need to compare it, and then we use Zero-Winkler algorithm. We say Zero-Winkler algorithm. Why we use Zero-Winkler? Because it is more about the position of the letters. So if you write math and Matthew, now because the 3 letters in the beginning is the same, it will give them more weight than the Levenshtein algorithm. So that's why we use Zero-Winkler in this type. And the last name, same things. So I am trying to build the features. So I am writing, so same things. And then the address, I use Levenshtein, because now every time I want to see how many distance or how many letters that we change when between the addresses. So this one will give me more distance if there is like not like a first name. Zero-Winkler is very weak when we searching for the address. And then the same things, we use it in the city because any different is a huge. And then about the date of birth, we need it exact, so we don't need to use any fuzzy matching on it. That so if he has same date of birth, we give it exact, so there's no fuzzy in it. So in same things in the zip code, so it's number. So because what's happened is fuzzy matching, it does not work with numbers, because if you work it with numbers, sometimes it give you distance wrong. So it's So with the zip code, we say exactly, and the state, same things, because it's 2-letter only, Kentucky or something. If there is 1 letter different, that is mean is a huge different. Okay, so now after we compare, so now we run our algorithm. We know what we want to compare, so we see how many number that we need to compare with. So we have 21, so 7 record generate 21 pairs to compare. Okay, so what we will do in here, we will generate a matrix. So this matrix from all numbers, so first name, how much different between the first record and second record, the percentage between the difference between the first name, the second name, and the address and zip code and city, etc. And then we try to classify the data. Okay, so in here. Okay, so after this is we'll build our features for doing. So now we need to classify. We need to see if this data is matching or not. So first one, we say we use threshold based classifier. So what's mean threshold? We say, okay, look at all the data, and then you combine all this data together, and then see the difference. If the difference between them is in the certain type, okay, matching is certain, lower than this value is not matching. To use this, so I have to use like a weight to give some of the information more weights. You can control the weights. So in here, to calculate the score, I give it weight. So in this weight, I say, okay, give first name and last name 50% weight, and then address less because 30% weight, and then the city 5, and the date of birth, zip code will be 10, and then the states 5. And then I will calculate it. So I am here, it's just not adding all numbers together and then divided. No, I give it the weight. So I would change this weight every time and see how much is matching. So if I run this, now start calculating, and then I can see the record. So first record, and here 1 and 0, it says the same because this is the difference between 1 and 0. So first record is 1 and 0, so the names different is 0.04. This is how much they are. And then in the last name, the 0.5. The address is 0.1. The city is 0.2. So the score after multiply the weight is 0.3. So that's mean obviously 0 and 1 is not matching. And then I go between 2 and 0. So 2 and 0, same things. There is no matching between first name and first name for the 0 and 2. Last name is 0, and then the address, and then the city is 0, all the other 0. So that you can see that between 0 and 2 record is the score is very low. If you go back to look at the data, and here, so this is 0, record 0, math, the record 2 is filler. So a huge difference between the two. And here Jacob, and then here Andrew. So there is a huge difference. The database is different. So you can look at between 0 and 2, the data is not matching. Between 2 and 1, there is some matching, but it's not that much also. So it's give 0.3 matching. And then I go with the 3. So the record 3 compared with 0. So you can see the name is 0.82. So this is 80% is matching. Last name is 88%, is almost 90%. The address is 90%. City is 100%, is the same. Date of birth is the same. And then in here, you can see the score is 80%, 0.8. If I can go and look at the 3 and 0, you can see 3 is Matthew and 0 is Matt. So Matt and Matthew, 80% match. Jacobs, 100% match. Date of birth is matching. The address is 100% match. City is match. Zip code 2042, 2024 match. And then I ignore social security in here. So there's no social security when we do it. So so because if it's same social security, it's done. So in here I am just using zip and date of there. So I ignore social security, so to make it more harder. So you can see that, and then we go to the rocket number 4, we compare it with 0, we compare it with 1 and 2 and 3. So we see that 4 and 0 is matching almost, and 4 and 3 is almost matching, but the other is not matching. And then 5 and 6. So because we are using threshold, so I am saying, okay, if the score larger than or equal 80%, this is match. If it is not, there is mean it does not match. They are not, they are different. So when we run it, we see that to say, okay, 6 and 0, 6 and 3, and 6 and 4, they are matching. So in here, so if I could add code, and then patients. So let's see the patients data. So look at the difference between the data. So it says in here 6, this is 6 Matthew, and 0 Matt, okay, and 3 is Matthew, and then 4 is Matthew. So so this one and this one and this one and this one is the match. So that's why it says 6 is matching 0 with this score, 6 is matching 3 with this score, 6 is matching 4 with this score. So there's now 6 and 0 and 3 and 4, all of them is matching. Okay, so this is when we use threshold. So let's say use machine learning algorithm to find the matching instead of we guessing which is threshold value that we are trying to figure out in here. So what we can do in here different, so I use k-mean classifier. So k-mean classifier is unsupervised classifier. So what's mean in supervisor classifier? That's mean you don't have to teach it. It will discover by itself. It's you say, okay, how many class do you have? So I say, okay, k-mean classifier is an algorithm. I say, okay, I saw in my data, I think my data has 2 classes. So matching or unmatch. So how many classes we have? We have only 2 classes. Okay, and then we look at the data. So the algorithm will go and then it start calculating the means. Okay, and then try to separate the means into 2 because we have 2 classes. So it will be generating 2 means. Okay, the average, 2 averages. And then look at the all points and then figure out the distance between all means. And then it will group them into 2 classes. Okay, so this is the algorithm. It's called k-mean algorithm. It's one of the machine learning algorithms that use unsupervised learning. And then when we run it, and here if you see, so I am using k-means, and then from the k-means I get all the data to it. The fact, this is a comparison factor. This is all the fuzzy matching of this data. I pass all this data to the algorithm. I remove the score, so there is no scores in it. So only this data, how much match, sorry, this data, I pass all this data and then send without scores. And I told him, try to figure out 2 classes in this data. One of them is matching, one of them is not matching. So the algorithm will go and they try to calculate the means every time. And then after it finishes, it iterate inside the data. And then it say at the end, they say, okay, in the matching class, there is 6 record is matching in this class. So there is 6 record in this class, they are matching. Which record is? This one, 6 and 0, 6 and 3, 6 and 4. So I don't have to give him a threshold and tell him, no, I need all the data above this threshold is matching, less than this threshold is not matching. The k-means algorithm automatically will calculate and try to figure out what's the match, what is not matching. Okay, so now we understand what's fuzzy matching and everything. But the problem is, fuzzy matching is really, really an issue. So what's the issue with the fuzzy matching? Is the limitation of fuzzy. So we see that we are using the Jerwinkler algorithm. We use Liebenstein algorithms. Both of them are fuzzy matching algorithm because what's happened is we're comparing each word with each word, and then we go to all the list. So we take math, and then we compare it with the whole, with one word. We see the distance between the two words, and then we go loop. So we loop multiple times to compare just one word. And then we have to generate multiple lists. So you see 7, we generate 21 records, okay, to compare with each others. So this is why if you look at it, it will be what? The time complexity will be very high. So we run it almost n square. So you can see that every time we increase the data, the time will be very high. So see, so until the end, we will reach in the same time. Let's say I'm working right now in University of Louisville, we have more than 1 million records. So if you go through 1 million records, it's really insane. Sometimes it takes more than 3-4 days to just run the algorithm to find out the matching. Imagine how you can do that, okay? It's really, really costly because every time you increase the data, the time will be very huge. Plus what? Plus the space. So let's say 7 records, we generate 21 records. So you see that? So from 7, we have 21, just to compare the 7. So how we fix this problem? So this is really huge problem, especially when you are running local machines. So if you have like local machines, some people maybe you use Hadoop clustering to run different, but it is still having an issue. So to fix this, how you compare this, so I'm gonna just give you an example how bad it is. Okay, there is an example in here. Okay, so I have a data. So in here I am running this query, run the upload file. Okay, so I am opening the file. I have this open source data, or open data from Europe, from UK. Has how many records? It has 3,000 something records in it. So it is not like too much of data. So I am running the data. Okay, load the data inside this variable. So I have 3,651 records. It's not 1 million, not 100,000. It's only 3,000. Okay, so now we want to do same things, but instead of comparing whole data, I want to see the time only. I want to look at the time if I have one word and one string, and then compare it with 3,600 string, and we see how much it will cost me in time. So I am bringing WASI. This is WASI, the library that implement Levenshtein algorithms. Okay, so I am loading the data. Okay, I get the only unique data from it, and then I say, okay, now start the processing, comparing this word, this sentence, with all the sentence inside my data. And then after I compare, I ask him to find out the time, and then so I get the time, and then I transfer the time from minute and then to hours to see how long it will take me to compare one record with 3,600 records. So I run it. Okay, now it took time. So in here, it finished. It said estimation to compare this sentence with all my 3,000 record. It will take a minimum, our estimation, 2 hours and have 60 minutes. So 2 hours and 30 minutes to get how long it will take me to compare just one with all the data set. Compare that you are bringing this data and then compare it with all this data together. So to make it more interesting, so we will use same way what we did last time, and then instead of using it and for 7 record, now we use it for 3,600 record and see the performance of our framework. So I am using the same library. It's called record linkage library, and then I run it. So to generate the pairs, we say we have to 3,600, and now we compare it with itself. So how many pairs we generate? It's 666,000 records. So just the 3,000 record to compare it so see how much we grow. So now we see 666,000 record to compare with. So we go through, so that 3,000 we compare it with 666,000 records. So imagine that we have million records. So how many? So I am same things. I am just comparing the names with names using Jero Winkler. Okay, and then I compare them. Okay, and then I generate the compute. So I compute the difference. Then I generate the factor. So it will take a little bit time. Now, even though it's just 3,000 record, with this one algorithm, this is running in the back with multiple machines. So we can see that how long it will take. See, because what's happened is this is exponential growth. So every time you could your data increase, it will increase. It take like amount certain minutes, but this is only 3,000 record. 3,000 is only one, maybe it's like 10% of the database dataset of one databases. So if you have a customers in Kroger, I think maybe you have thousands of thousands that they open a loyalty card for Kroger every hour. So imagine how many. If you have Facebook or you have any information, imagine how many data set that you have. So this is not practical with the big data. So if you have a lot of data, it's really bad. However, if you compare now, we just compare and we use same information. Okay, so I am just looking at it. So it's say, okay, the record 2 is equal to 0, record 2 is equal to 1, 3, 0. So in here, okay, so in here I just compare between all the data and say, okay, 190, the index 190 is equal to 65, 178. So I am looking at this information. I can find that 190. This is, so because we are using Winkler algorithm, just as is we are doing. So both three of them, they say that matching, because of three of them start between the same spot. So London, London, London. Even though it's different, but he says that they are, three of them is the same, because what's happened, all the two words in the beginning is the same. Okay, so they are like, they figure out the same. Okay, so this is the problem of fuzzy matching. So now, how we solve this problem and overcome the problem of fuzzy matching approach? We know that we are like looking at what? Words. We're looking at text. So this is one of the machine learning problems. And there is a field we call NLP, or natural language processor, the deal with this type of problem. So like, let's say you want to see positive, negative comments, you want to see certain class, certain notes. We use natural language processor, NLP algorithms to figure out. So we have sometimes multiple algorithms inside the natural language processor. So one of the algorithms that we are using, we call term frequency and verse document frequency, or TF-IDF. So what's TF-IDF is only algorithm that looking at all words. Okay. So consider this. So what's happened is you have a document. Okay. Inside this document, this algorithm will try to count all the words inside that document. So each word, how many? So we know that the word that mention a lot inside the same document, this is very important inside that document, this word. But if you have like thousands of documents and all of them has the same word and all of them, this word is not important anymore. So if it's important, if it is repeated in one or two documents, but if it's repeated in all documents or the majority of documents, that means this word does not have a meaning or does not have an important meaning. Like let's say that. So the word that may be repeated thousands of times in one document, but it says this is important, But if you compare it with another document, you will find this word is repeated, same things with multiple documents with the same thing. So this is will be what the meaning of this word will be reduced. But if we have a one word, let's say communication, and then this word communication is when one document is repeated a lot, but is not repeated in the other document. So we know that communication is very high meaning in that document compared to the other document. So this is how it is work. So imagine that. So this is how it is. We try to figure out a word that repeated multiple times and very important, and not repeated in other documents. So we compare between two strings. So if you have one thing that comparing between three strings to see how much is similar, if it is repeated in all of them, this means similar. If all the words is repeated in all documents, this means the two documents is similar. If it is not repeated, this means and it's shown in one document is not shown in the second document, this is will reduce the similarity between the two. So the term frequency or inverse document frequency. So term frequency, this is we count how many times this word being repeated. Inverse document frequency, if it is repeated on all document, we reduce the weight of that word. Okay, and this is really nice. We use it for a lot of products to find out our text classification problems. Okay, so how does it work? So now we have the same things, same way that we're using fuzzy matching. Now instead of fuzzy matching, we're using NLP algorithm or term frequency algorithm. So what's happened? We have the two sources in here. We have algorithm we call n-grams. What's mean n-grams? N-grams, we take the word, let's say department. We say, okay, three. So we went to compare two words together. I cannot say, okay, now if I have a document, I will compare word by word. If I do, I have small names. So I have one name and then another name. How I can compare? Because they are both of them have the same name or they don't have the same name. So what we will do, we split each three character together or each two together, and then we compare. So let's say Matthew. So we say MA by itself, AT by itself, TT by itself, and then Matthew, MA by itself, AT by itself, TW by itself, and etc. So now, when we start to see how much the difference between the two. So we can see that MA is repeated, AT is repeated, TT is repeated, and then we can find the similarity between the two, and then we build the matrix of TF IDF, our term frequency. So instead, if we have a document with a lot of text, we use it word. If it is a word by word, we use characters instead of that. That's why we use n-gram. And this one, I use a scikit library. This is a free library that use machine learning also. So it's free to use it. Okay, so now I am, so look at the example that we go through. So sorry, where is it? Okay, so in here, so this is an NLP approach. Okay, so I am using NLP instead of fuzzy matching. So now I run it. I bring the all library that I need. So I need cosine similarity. So what's happening is exactly, so the algorithm will work in this way. So I get this, and then I build my matrix or factor, because TF generates factor. It does not generate a number. It's not generate like a fuzzy matching, how much the distance between the two words. This one will build a factor, how much like a number and a degree for each one of them. So the matrix in here is different. Okay, so that's why we're using cosine similarity instead of using k-means classifier or threshold value to classify. So that's why we use cosine similarity, because TF matrix generate factor is not a value. So, and then after that, we store the data, and then we say this is matching or not matching. Okay, so in here, where's my, okay. Sorry. Sorry. So let's say go to our Python. Okay, where is that? Okay, record linkage. Okay, so now, so we use cosine similarity. Why cosine similarity? Because after we build the library, the matrix, because of this factor, we want to see each record how much far away from the other record. So that's why we use the cosine similarity. And then here we use the term frequency library to generate the factor. Okay. And then, so this is anagram that we split the word into 3 characters. So I am saying 3. So I split into 3 words. Okay. So I am now running this one. I bring all the libraries. I store all the information about the names. Let's see the data, the same data that I use. So this is the names that we have. So we have multiple names, okay? And then we go through it and try to compare which is matching each others, okay? So this is the data I have because it's unique. Now we try to, this is 3,600 record, okay? After I load the data, now we try to build our cross similarity or cosine similarity. This is the function of cosine similarity. Okay, load all the data that we need. You can use cosine similarity that provided library, or you can build it by yourself. So you don't have to build it by yourself. But this one is more faster. That's why I use it. This is from one guy. He wrote it, and I like it because it's really fast. And so what's happened with the city is have a lot of validation on it. So if you have any problem, it may like try and catch it, doesn't throw the error even there is an error. So when I write my function by myself, if there's an error, I can figure out where is the error, and then I can fix it. So I run the function, and then here try to go and then loop through the matrix and then find the match. Okay, run it. This is the matching to find the match, and then in here just running the match. So it's, I say, okay, I am using cosine. I pass my matrix, and then I pass the other matrix, and then I see what's going on. And then after I get match, I want to print the match. So if I run it, now it's very fast. This is 3,600. It does not take even a second. Why? Because the running of this algorithm is linear. It's like the same exactly if your data 3,000 or your data 100,000. So you see that it will bring the similar data set. So this is the University of Chadis. This is the same, almost the same. So this is the similar to this. You see there is a difference, and then he give you the cosine similarity, how much they're similar to each other. Okay, so this is none, so there is no similarity. And here, so everyone is bring only the similarity that above than certain value. Okay, that's so this is NLP problem, how we can solve it. We make it fast. So you see that if we use only fuzzy matching to build our features and see the difference between the two words, it takes from us 2 hours to compare 3,600 rocket. If we use machine learning or NLP algorithm, you can use machine learning or fuzzy matching too. But if you use NLP problem to find the match, in here we only maybe seconds to run all 3,600 rocket to find the matching. So it's really huge difference between the two, especially when you have big data sets. Okay, there's another way. So maybe we can about the futures. There's another one algorithm that I like. It's called active learning. And this is another library. It's called from Dedup. It's not free, but you can test it. Dedup is using active learning. What's mean active learning? You upload your data, and then after you upload your data, you tell him, find a match. And then he will bring you the data, and they say, ask you, is this two match or not? If you say yes, match, and then it's learn. So it's learn every time it find the match, and then try to figure out. So it's really nice library. How the only thing is interactive, and is not free. And for production, it's free for programmers. You can use it, you can download it and try it. Okay, so it's good. It is a different way of learning. It's like support. They call it supervisor learning. So supervised learning, that means you try to teach the algorithm every time that he find a match. So you say, okay, this is match, this is not match, this is a match, this is, and then every time you try, the system will learn and then become better and better. However, this has a problem if it is, because if your user is making a mistakes multiple times, this mistakes which will be an issue with the algorithm later on. So it's independent also and the user itself. So the good things with fuzzy matching, K-means algorithm is unsupervised learning. It's unsupervised learning. That means this algorithm will learn by itself and try to learn from the data without interacting with the people. And then it just give you the percentage, or they give you likelihood of this record is matching. The end of this talk, I think this is my end. If you don't have any, if you have any question or anything, so you can free to ask. If not, thank you very much for your time, and I hope you learned something about how we can find the duplication for data without primary key to figure out the same data set. And we can use this one. They use it, this approach. We use it also for like journal of the someone copyright and stuff like that. So it's not like this. So if you have someone write an article and then he copy multiple things, we can find the similarity between different articles, different papers, different stuff to find the similarity. Okay. So thank you very much, and really appreciate your comment. If you have any comment or anything that you need to learn, thank you. Thank you very much. Thank you, and have a nice day, and thank you, and thank Code PaLOUsa for giving me this opportunity to talk about what we have and real problems that we face in our companies and our real data. So this is a problem we have it in so I work in University of Louisville, we have it, and then I work with the Mortensen partner, we have the same problems. And this is, so this problem is really the core of the giving excellent services for providers to the patient, or is good for targeting people and the customers, like in Kroger or Walmart or any other stores. Okay, thank you. Thank you very much. I'm out right now. If you don't have any question, you're free to go. Thank you.